Right. So last class we have completed. Right. Last class we have understood class loader subsystem functionality, right? Any doubts, any confusions? Have you read these points in your notes? I hope you remember. So how many steps are there in a class load? I mean, a class searching algorithm? How many steps are there in class searching algorithm? Okay, 14 steps are there. What is the algorithm following by class loader for finding the class? Parent delegation hierarchy algorithm. Right? Why parent delegation hierarchy algorithm is implemented? For giving first priority to predefined classes to load into JVM. In what situation predefined classes are not loaded into JVM? In what situation predefined classes are not loaded into JVM? We can create predefined classes. I mean, we can create user defined class with the same predefined class name. In that case, if parent delegation hierarchy algorithm is not implemented, if application class loader directly searching for the class in application class path, then our class predefined class is not loaded. Our class will be loaded into JVM. To overcome this problem, parent delegation hierarchy algorithm is implemented. Okay, what are the changes happen in Java 9 version? In Java 9 version, jar files concepts are removed, and now the jar file contain hundreds or lakhs of classes. Those lakhs of classes are divided into small modules. So module concept is introduced. Then also extension class loader mechanism is removed. And third one, we cannot use predefined package name as user defined package name. If you try to use compiler, if you try to use compiler will throw error. So these are the changes we got in Java 9 version. Okay, now the next point I want you to understand today. Okay, now I want to repeat the flow of execution once, and then I want to continue next points. Okay, now when you run Java example, first JVM runtime data areas are created, and JVM searching for example class bytecode in method area. In method area, example class bytecode is not available. Then it requesting class loader to load the class. Then class loader has give the request to application class loader. Application class loader searching give the request to extension class loader. Extension class loader delegate the request to bootstrap class loader. Bootstrap class loader searching for the class in bootstrap class path. In bootstrap class path, the class is not available. Then the request, bootstrap class loader will throw class not found exception to extension class loader. Extension class loader catch that exception and search for the class in extension class path. In extension class path, the class is not available. Then extension class loader throw exception to application class loader. Application class loader will catch that exception and search for the class in application class path. In application class path also, if class is not available, it will throw exception. In application class loader, the class is available. In application class path, suppose the class is available, then it will load the class bytecode into JVM. Inside JVM, how many runtime data areas are there? 5 runtime data areas. Then now where this application class loader must load the class bytecode? Inside method area. Okay, inside method area it should load. Okay, now my question, method area is having lot of memory, right? Method area contains lot of memory. Then will class bytecode store in this entire memory? Will it occupy this entire memory? No. Okay, how much memory required for this bytecode, that much memory only will be used. Okay, now. So 9 a.m. batch, offline students, are you here? Did you join? Offline students, hope you got information to join here. Okay. Now all the people listen. Now today we are starting. We are continuing with the next topic. Okay. We are continuing new topic today. Continuation to yesterday class. I want to store student. I want to store student information in Java. I want to store employee information in Java. I want to store bank account information in Java. I want to store bike information in Java. I want to store laptop information in Java. Then tell me, how will you store all these real world objects information in Java? Two steps. First, you create the class. Inside class, you declare variables, define methods. From this class, you create instance 1, instance 2, instance 3. For employee also, you create a class with properties and methods and create first instance, second instance, third instance. Create bank account object and create first instance, second instance, third instance. Now all the people think and tell me. For creating student, we have class student. For employee, class employee. Bank account, class bank account. Bike, class bike. Laptop, laptop. Similarly, if you want to store class bytecode inside JVM, if you want to store class bytecode inside JVM, come on. If you want to store class bytecode inside JVM, I required one object na. I want to store student data, student class and student instance. I want to store object employee object data, class employee, data employee. I want to store bank account, class bank account, new bank account. Similarly, I want to store class bytecode inside JVM. Is a bytecode is a one value or multiple values? Multiple values, multiple things are there. Then how can you store multiple things? By using object. From which class the object is created? Sun Microsystem has given one predefined class to us. Okay, Sun Microsystem has given one predefined class to us. Okay, it is available in java.lang package. That class name is, come on, student, student, employee, employee, bank account, bank account. Same way, class, class. Okay, so we have one predefined class called java. In java.lang package, we have a predefined class called class. What is the name of the class? Class. We have one predefined class called class. Is it clear, buddy? Java.lang.class instance is created. In this java.lang.class instance, now the given class bytecode is stored. Given class bytecode is nothing but the class information. Okay, so the class name, it's a super class, implementing interfaces, its modifiers, and its static variables. Okay, static variables, and then what? Static blocks. Next, non-static variables, instance initializer block, nothing but, okay, for your understanding, I'm writing non-static block. Next, what? Constructor. Then next, static method, non-static method. Okay, static inner class. Okay, inner classes will not be here, it will be separate. And then finally, main method. Okay, complete information about the class is stored inside JVM by creating java.lang.class instance. Everyone understand that? So repeat once again. Repeat once again how a class bytecode stored inside JVM. A class bytecode is stored inside JVM by using java.lang.class instance. This is step number 15. Okay, nobody? Okay, then tell me, after class bytecode stored into JVM, what are the next steps? All the people know. Now class is loaded. Now class loader subsystem responsibility completed? Still not completed. Class loader is responsible to perform totally 3 activities. Number 1, class loading. Number 2, linking. Number 3, initializing. How many activities it has to do? 3 activities. Class loader subsystem is responsible for performing 3 activities. What are the 3 activities? Loading, linking, and initializing. Loading, linking, and initializing. Okay. Class loader is responsible performing loading a class, linking a class, and initializing a class. What the meaning of loading a class? Finding the .class file, reading its bytecode, and storing inside JVM by creating java.lang.class instance. Okay, now. So that's what activity completed just now. Just now, class loader completed its activity, what? Loading the class. After loading class, now I want to link. Class loader has to responsibility perform what? Linking a class. What the meaning of linking a class? Linking is nothing but verifying the loaded bytecode valid or not. Okay. Now linking has totally 3 activities: verifying, preparing, and resolve. Okay, verifying, prepare, and resolve. So loading, linking, initialize. Loading phase contains what? Finding the .class file of the given class, reading the bytecode, and store the bytecode inside JVM in a method area by creating java.lang.class instance. After the loading is completed, now class loader is responsible performing linking. Linking means incorporating loaded class bytecode into JVM runtime instance. What the meaning of incorporating? Making this class ready to execute. Incorporating means making this class ready to execute. Making this class ready to, convert this class to be executed by JVM. Convert this class to be executed by JVM. For example, I'm taking one room for rent to take the class. Now I wanted to run your session. To run your session, now just by taking one room for rent, is it sufficient? No, I should make this class ready to execute now. That means what? I have to add fans, I should add lights, I should add projector, I should add table, computer, chairs. So all the required setup I have to do, and then I should supply power. I should supply power to run all these things, right? So same way, just loading the class is not sufficient. It has to incorporate. What the meaning of incorporating? So making this class understandable to JVM and ready to execute by JVM. Making this class ready to execute by JVM. For that purpose, for this incorporating purpose, JVM implicitly doing how many activities? 3 activities. What are the 3 activities? Verifying, preparing, resolve. What the meaning of verify? It verifies the loaded bytecode is according to JVM understandable way or not. Okay, and it will do a lot of verification. Almost 10-15 steps are there to verify. At this stage, you cannot understand all the points. Okay, in coming classes, I will explain you. So at this minute, only one point to remember: the loaded bytecode is valid according to JVM format or not. It is verified. If complete bytecode is valid, then now next stage it is going to what? Prepare phase. What the meaning of prepare? Prepare is nothing but allocating memory for static variables with a default values based on the data type. So up to now, you all people are feeling that once class loaded into JVM, JVM executes main method. No, before main method, what is executed? Static variables are executed. All static variables from top to bottom will be allocated memory. So tell me, after class loading into JVM, what is happening now? After loading into class, what is happening now? Allocating memory to static variable. Okay. Static variable memory allocated with default value. Okay, allocating memory with a default value. So the default value based on the data type. DV means default value. So now if static variable is int type, default value 0. Static variable type is a double, default value 0.0. Static variable type is char, default value true, sorry, null character. So if default value is a boolean, false. If a default value is array type or any class type or string type, nothing but reference type, then default value null will be stored. Okay, now. So tell me, now JVM has completed what prepare phase. So class loader is responsible for linking a class. As part of linking, it verify the bytecode and then prepare the prepare the memory. Prepare the memory is nothing but allocate memory. Next, once the memory is allocated with the default value, tell me, this default value must be replaced with given value. No? This default value must be replaced with what? My own value, GV. GV stands for given value. So I'm giving my own value, let's say 10 or some P or some false or true or string, anything. So I am giving my own value. So now you have to inside this what do you call static variable, the given value should be stored. So storing value inside static variable technically called what? Initialization. Okay, now it's the time you need to get some clarity on bytecode. Look at here. I wanted to run the class example.java file. Okay, this example.java file I wanted to run. Why this release and I return? Okay, I have written small program like this. Save it. Go to command prompt. Java ca.java I compile. Then compiler generates background bytecode. Java A. Okay. Java A, press enter. When you run, program executed 50 stored. But I want read bytecode. Any of you remember what the command for reading bytecode? Java P na Java PA. When I run Java PA, only it is showing the declaration of the member of this class. Class A contain main method. Main method declaration only will show to us. But I want to execute, I want to see the logic of this entire class. Complete bytecode I want to see. For that, what is the shortcut I should use? Java P hyphen verbose A. Java P hyphen verbose A. Press enter. Look at that, there is a huge bytecode scheme. Okay, I want to take this entire story into edit plus for your clear understanding. Look at here, this is bytecode. Java P hyphen verbose A, this class file, okay, coming from A dot class. This is the path and last modified date. Okay, class A, minor version 0, major version 61, some number it is maintaining, and flags, current class is A, its a super class is java.lang.object. Did you notice after this class, we have some symbolic reference. Symbolic reference, hash 19, hash 2. Okay, these symbolic references are available inside constant pool. So the complete class information is stored in the format of a table. Okay, so it's called constant pool. Now table contain symbolic reference and its actual reference. Okay, now hash 1 is symbolic reference. It representing actual reference, method reference, hash 2 dot hash 3, which refers to java.lang.object is actual reference, hash 3 representing dot init, nothing but constructor. Okay, so the complete class bytecode, the complete source code is rearranged as what? Symbolic references matching with actual references. Now inside program, if you go to main method, inside main method, there is a statement called get static hash 7. Then tell me this, if with the hash 7, JVM can execute this program? No. This hash 7 symbolic reference must replace with actual reference. What is the actual reference? java.lang.system.out. Right? This hash 7 refers to what? java.lang.system.out should be substituted here. Now invoke hash 13. Hash 13 is symbolic reference. That symbolic reference must be replaced with actual reference. What is that? java.io.printstream class println method should be substituted here. So at compilation time, compiler software places symbolic references. Okay, later JVM to execute purpose, these symbolic references must be replaced with the actual reference. This process of converting symbolic references to actual reference is called what? Resolve. What we call a resolve. So class loader is responsible to perform 4 activities. Number 1, loading class, linking class, and initialize class. Loading class means finding the dot class file, reading the bytecode available in this dot class file, and storing the bytecode in the method area by creating java.lang.class instance. Second, linking a class means incorporating the given class bytecode into JVM runtime instance, means inside JVM runtime memory make this bytecode available. To make this bytecode available and ready to execute, it implicitly perform 3 operations. Number 1, verifying. Number 2, prepare. Number 3, resolve. In verifying phase, it verifies the loaded bytecode is valid according to JVM requirements. And then now further it is in the prepare phase, it will prepare what it will do? It will prepare memory for static variable with the default value. Okay, in the resolve phase, what it will do in resolve phase? In resolve phase, it will replaces symbolic references with actual references to ready to execute. Okay, now after these 3 phases completed, then it will go for initializing a logic. Tell me in the initializing class. Okay, initializing class is nothing but executing static block logic. Okay, execute static block logic and initialize static variable with given values. So in the prepare phase, static variables are created with the default values. Now these default values are replaced with now static block given logic. So in the static block logic, like how you have seen in the main method, hash 7, hash 13. In static block also internal logic contains what? Symbolic references. Now, those symbolic references are replaced with actual references in the resolve phase, and initialization phase, static block is directly executed. Everyone understand? So static block logic is executed. Static variables are initialized with given values. Then tell me now, after memory allocation completed here, what the next step? This static block logic should execute. Can you please all try to answer? Static block is a logic. Where it is executed? In method area, in heap area, in Java stacks area. Where? Come on, expecting answer from everyone. Where it is executed? Where logic executed? Logic must be executed in? You know already. Logics executed in heap area now. Oh my God. Logics are executed in? Logics are stored in method area, bhaiya. Logics are executed in Java stacks area. Okay. So tell me, inside Java stacks area, inside main thread, logic will be executed. Okay. Inside Java stacks area, inside main thread, logic is executed. Okay. Here, the static block logic is loaded. Okay, na? Here, static block logic is loaded. Open bracket, close it. Static block logic is executed, loaded, and the static block logic is executed according to given logic. According to the given logic, what happened? Tell me now. According to given logic, The static variables are initialized with given values. Is it clear to everyone? So what is the responsibility of class loader? Class loader is responsible to perform how many steps? 3. Number 1, loading. Number 2, linking. Number 3, initializing. So class loader subsystem responsibility completed. Now class loader makes the class ready to execute. Right? Class loader job is completed. Class loader makes the class is ready to execute. Then who is responsible to execute class? Class loader is responsible for loading class and make it ready to execute. Who is responsible to execute class? Execution engine. Right? Execution engine is responsible for executing the given class. Now execution engine implicitly contain how many members? Execution engine internally contains 5 members. What are the 5 members? Interpreter, JIT compiler, hotspot profiler, security manager, garbage collector. All these 5 members together, we call it as execution engine. Okay. Now execution engine is responsible for connecting to JVM runtime system, runtime data areas for executing logic by allocating required memory and objects, and also responsible for destroying those objects by using garbage collector after their usage complete. Okay. Now execution engine is coming to picture. Now it loads main method here. Okay, it start running main method. Now main method has permission to execute. Main method logic is executed here. As part of main method, you may create object of this example class. Then example class is the object created where? In heap area. Are you following? With reference 1010. Now non-static variables. Non-static variable memory allocated here with the default values. All are following? Okay, tell me. Who will initialize object? Who will initialize object? E is a local variable, right? Local variable is allocated a memory inside. So variable is a local variable. Local variables are allocated memory where? Inside main method, right? Inside the parameter. I mean, inside method stack. So inside, do you remember local variables are called stack variables? I told you. Stack variables memory allocated inside where? Java stacks area. Okay, next. Tell me, who will initialize object? Object is initialized by constructor. Object is initialized by constructor. Then constructor logic is loaded here. Okay, na? And then according to constructor logic, what logic you return? Storing default values, right? I mean, storing the initialized values inside constructor according to the logic of constructor. Now this non-static variables in this object initialized with default values or given values. According to static block logic, given values are stored inside static variable. Okay, na? According to now constructor logic, according to the logic given in constructor, now given values are stored in the non-static variables. Up to now, understand everybody? Then further, after this memory allocation completed, constructor execution completed, reference is stored here in E variable 1010 and it is point. So the objects created in heap area and the referenced variables are created inside Java stacks area inside a main method because they are created inside main method. Okay. All people understand up to now? And tell me. Okay, tell me next. Assume that in main method I call static method. Then static method loaded here and executed here. Right? Tell me. Assume that using object I have called non-static method. Then non-static method logic is also loaded here and executed here. Okay. And very important point, inside static non-static methods, if you have any parameters, and then the parameter variables, I'm writing P stands for parameter. Okay. The parameter variables and local variable, M stands for local variable. Local variables memory created here. So this is the complete JVM architecture understanding. So after class loading, how many steps are happening background, you must visualize. Okay. After class loading into JVM, first class loader allocate memory to static variables with the default value. Then class loader executes static block. Class loader executes static block. Okay. With given values. Static block executed and static variables are initialized with given values. Then class loader completed its responsibilities, loading, linking, and initialize. Then execution engine came into picture for what purpose? For what do you call for starting class logic execution with what? Main method. Okay. Inside main method, if you create any parameter, any object, then the object is created inside heap area with non-static variables default values. Later, constructor is executed. Those default values are replaced with given values. Okay. And if you call any static method, static methods and non-static methods are loaded inside Java structure into main thread, and parameters and local variables are allocated memory in their memory execution. So finally, what the conclusion point? Class bytecode is stored here. Class bytecode is stored inside method area. Class bytecode is stored inside method area. Static variables memory allocated in method area. Non-objects are created in heap area. Non-static variables memory allocated in heap area. Next, static block, main method, non-static block, constructor, static method, non-static method. All blocks logic executed inside Java stacks area inside main thread. Okay, now these are all the points you have to remember. Then now my question is, assume that Java is multi-threaded programming language. No? According to multi-thread programming, what can I do? I can create multiple threads. So inside Java stacks area, in addition to main thread, I can create my own new threads. I can create my own new threads. By default, whenever I ask JVM to create new thread, JVM create the thread by using the name thread-0. Okay, na? Thread-0. And next, you can create a number of threads, your wish. I can create one more thread. Yeah, one more thread created with the name thread-1. Okay, like this, I can create n number of threads. Okay, nobody? Whenever new thread is created here in Java stacks area, now immediately it's respect to program counter register. Thread-0 PCR. Thread-1 PCR. Thread is nothing but stack. In C language, you call stack. In Java, we are calling it as thread. Okay, now. Next. Now, whenever you create a custom thread, then respect to native stack is also created. This is thread-0. I'm writing shortcut space problem. Thread-0 native stack. This is thread-0. Thread-1 native stack. Custom thread means your own thread. Custom class means your own class. Custom means user defined, our own. JVM by default has given main thread. I want to create my own threads, user defined threads. And now all people answer. Inside main thread, I call one native method. Okay, I call one native method. Then now that native method logic is executed in Java stacks area or executed in native method stack area. It is executed in native method stack area. Then there are some predefined native methods are there. Your favorite methods, sleep method, okay, join method, wait method, get class method, okay, get class method. Like this, there are some predefined methods are there, which are native methods. When you call these methods inside our main method, their logic is loaded and executed inside native method. For example, if these methods are called inside thread-0, then they are executed in thread-0 native stack. If you call native method inside thread-1, then they're executed in thread-1 native stack. Okay, nobody? Now the question is here. Now the native methods logic is not available in Java. Native methods logic is available inside where in a hard disk. Now those methods has to be linked. For linking those methods, we have Java native interface. Now what we call it as Java native interface? JNI. People are calling it as JNI. Now this JNI is linked to whom? Native method stack area. And also it is interacting with execution engine for executing that native methods logic also. So any type of method should be executed by execution engine only. Okay, na? So this is the full JVM execution flow. So if you have any questions in this diagram at any place, you can ask. There are no native classes, native methods only. Static variable get memory in method area. Main thread, main method area. Where it provided memory here only, na? Interviewer will never ask this question, don't worry. It is not memory, buddy. Non-static variable declaration statement. Inside class, when example class is coming along with the example class, all the variables and methods declaration and logic will be there, na? So this is non-static variable declaration. Then it's memory allocated in a heap area. JNI is nothing but predefined program, predefined library functions. Okay, predefined library. It is responsible for linking Java method, Java native methods. When you call Java native methods, its background logic is linked. Okay, now. So this method has a background logic inside C native functions. Those C native functions are linked to this sleep method to execute its logic. Okay. Java.lang class instance is created by class loader. It implicitly created by class loader. We don't create. When you run Java example to load this class bytecode, class loader will create. Any more questions? If I give time to ask questions, people always ask useless questions. That's why I don't never give the time. Unnecessary deviating from the points. What the use of sleep method? Is it necessary to know now? Is it necessary to know now? What the use of sleep method? What is the join method? If I give, that's why generally I don't like to give the time to ask questions. How class object converted to our object? What is the meaning of this question, buddy? Vikram? When I give a chance to ask questions, so ask some meaningful questions, buddy. Current topic is JVM architecture, right? So sleep method, join method are some of the native methods. Those native methods, when you call, wonderful. Did you miss previous classes? Suman, did you miss previous classes? Fine. So now I'm not taking any questions from you because you are asking questions out of discussion. Unnecessary, you're feeling that I must ask questions, so you're asking, okay? So that's why I'm not taking any questions. Hope you all understood what I explained is sufficient. Okay, right. Now I want to ask another question. Ready to answer? Where this program explanation there and daily come to the class and listen class properly. Okay. Already I gave the page numbers also, right? Where this entire diagram there, where it is information there. Come on, guys. I want to ask question. Assume that inside main method, I have created a sample class object. What will happen? Tell me all. Assume that inside main method, I have created sample class object. Sample variable created, right? Sample variable memory created here. Then to create sample class object, the class must be available in JVM. Na? Where sample class is available in hard disk. It is not available inside JVM. JVM execute classes, those are available inside JVM. Then from Java stacks area, JVM will go to method area because classes are available in method area. In method area, the class is available or not available? Not available. Then what JVM will do? It will request class loader to load the class. Class loader will apply parent delegation hierarchy algorithm and it will start searching for the classes. Application class loader to extension to bootstrap, bootstrap to extension to application. Then application class loader found our sample class in current directory. From current directory, it is loading the class into JVM method area, into JVM method area by creating, by creating separate class instance. As many classes are loading, as many students you want to create, those many student instances are created. Same way, as many classes you create, those many, as many classes you are loading into JVM, those many instances are created. Java.lang class instance is created. And then here class sample loaded with its a static variables, declaration, static block logic, non-static variables declaration, constructor logic, and the next static method, non-static method. And if you have any main method, okay, na? Whatever, all members are loaded. And after that, tell me, it will allocate memory for what? Static variable, and then executes static block, initialize static variable with first given default value, then static block executed in Java stacks area, and then now it is initialized with given values. Then next, now the new keyword came into picture. New keyword creates object of sample class with its non-static variable memory with a default value. Then constructor executed, given values are stored. So final conclusion, what I want you to understand, all classes are loaded and stored inside method area by creating separate java.lang.class instance, and all classes objects are created inside heap area. Okay, from heap, and their local variable, reference variables as a local variables are created inside Java stacks area. From Java stacks area, it is pointing to. Okay, and all classes, blocks and methods logic executed inside Java structure by inside main thread. So this is the clarity you must have. Finally, again, I'm asking question. Without loading class into JVM, without executing static variables and static blocks, your program is not ready to execute main method, or your program is not ready to create objects. Either you want to execute main method, or you want to create objects. First, you have to load the class, execute static variables, and execute static block. Okay, na? Hope everyone comfortable. Don't think too much. Okay, if you think too much, the problem will come. I will give you, okay, final conclusion of this diagram. Final conclusion of this diagram, tell me, do we need to worry about complete JVM architecture for every program? Not required. So we need to worry about only, okay, you should have an idea of how the class loader subsystem working background. And then you must have an idea of how execution engine working background. Then in detail, you should know about method area, heap area, and Java stacks area. Do we need to worry about program counter register area and native method stack area? Not required. So completely you have to you have to simplify this memory diagram at 3 levels. What is that? Method area, heap area, and Java stacks area, that much. Okay, now. So now I wanted to give you 3 programs now. So JVM architecture completed, JVM internal components explanation completed, all points you got clarity. Now what you need to understand? You need to understand now practicals. So how the given programs are executed inside JVM, that is what you want to understand in this chapter now. So I'll give you 3 programs. The 3 programs I want you work with JVM. Are you ready? This is the program I am giving you. Right on. Draw JVM architecture. Draw JVM architecture to show the memory, distribution of static variable, non-static variable, parameter, and local variable for the below program. Okay, I'm giving you 5 minutes time, expecting all you people to work yourself. Right. Hope you completed. I hope you created Java stacks area also clearly, right? Okay, let me try to show you diagram from my way. Java example.java when you run. Java example, JVM is created. With five runtime data areas, we are considering only 3 runtime data areas: method area, heap area, Java stacks area. Okay, 3 runtime data areas we consider. Then JVM searching for the class example in method area, not available. Then it requesting class loader subsystem. Okay, it's requesting class loader subsystem to search for the class. So class loader is performing totally 3 activities: loading, linking, initializing. So now class loader subsystem is found the class loaded by creating java.client.class instance with the class example and its members: static variables declaration, non-static variables declaration. Tell me, you have created main method next. Inside this class, do you have any additional members inbuilt available? Who is responsible for initializing static variables? Static block. Who is responsible for initializing non-static variables? Constructor. So even though you have not created, compiler software implicitly creates constructor, main method, then static block. Okay, got clarity? Yeah? Next, now JVM class loader completed loading phase. Next phase is what? Linking. The linking phase, it is verifying the bytecode. And then after verifying bytecode, it is allocate memory for static variables. It will allocate memory for static variables with the default value 00 because data type is int. The next step is what? Prepare and then resolve. After resolve, initialize. In initialization phase, and now static block is loaded into main thread. Static block logic is executed. So A equal to 10, B equal to 20. Static block logic executed. 00 replace with value 10, 20. Okay, now. Then static block execution complete. Next, it is running main method. Now main method is loaded here by occupying some memory in main thread. Then what the first statement executed? Have you drawn args variable? I don't think so. Args is a parameter, na? Parameter memory created. JVM implicitly create empty string object reading runtime value chapter. String array object is created. Empty string array object is created. Reference 10 and stored here. Point. Next line, local variables P and Q variables are created in memory. Next line, example E1. E1 is a local variable. Equal to new example. What the job of new keyword? New keyword job is allocate memory for object non-static variables. New keyword calls go to class example, found the non-static variables xy. New instance is created, xy variables memory created with the default values. Am I right? Have you completed these things? Now to initialize these non-static variables, new keyword calls constructor. Now constructor logic from method area loaded into Java stacks area, background logic executed, 00 replaced with 30, 40. Then constructor logic completed, new keyword return reference and stored in E1 pointing to it. Okay. Then next line executed. Tell me, example E2 variable memory created. The new keyword again will go to example class and found non-static variables. Allocate memory to non-static variables, one more call. Again new keyword call constructor. Again constructor logic is loaded. Again constructor logic executed. In this new instance 20, 30, 30, 0, 0 replaced with the given value 34. Okay now? Then after construct execution completed, new keyword return, what do you call, reference 30, 30 stored in E2 variable pointing to it. Okay. So this is the program, and background, you must visualize this program not as a program. You must visualize this program as a JVM architecture like this. Then you can understand any program easily. You can solve any question easily. Can I hope all people are comfortable? If you remember your father given name to you, then you don't forget Java also. You join to the class with the name administrator. To whom you are administrator, Ravi? And you are asking one wonderful, dirty, idiot, stupid question. Static variables allocate memory in object or not? E batch student, Ravi. Which batch student are you, buddy? This batch only. This batch only. Okay, you join with administrator, it's okay. But what is that question? Is it okay, that question asking? Static variables part of object. Should I school or not school? Other students, all people understood? So today onwards, can you visualize JVM architecture for the given program? So tomorrow, we will try to complete remaining 2 programs, that is machine language code executes by JVM with OS help. Yesterday I shown you process-based virtual machine replicate OS functionality to execute program in a platform independent way. Okay. JVM only executes machine language code. Okay. So tomorrow we'll complete JVM architecture chapter remaining 2 programs. Tomorrow also all the people join online only, no offline class. I cannot come to offline now. Please also tomorrow also continue online class. Okay. Thank you guys. See you all tomorrow. Bye. Any questions in today class? Still any questions?